Because for some of the elements, you don't want to allow null value. Yeah, null value, we know it's a special value. Yeah, give the users kind of warning. Yeah, you need to fix it. So there is a problem. You need to fix it. Yeah. So not null. Yeah. So if we don't want to allow that, yeah, sometimes for some business reason we don't want to allow not null value or null value. Yeah, we don't want to allow null value in some particular field of a table. Yeah, we can put this constraint, not null constraint. Yeah. So when an attribute does not allow the null value, we just, append this constraint right off, at the end of the field declaration. Yeah. In this way, if the value is not provided, yeah, you need to consider the consequence, right? If you add this constraint, the consequence, what's that? So then, if at the input time, if the user does not provide a value for this field, then the DBMS will reject the input, reject it. If you do not provide value, reject it. Okay? Yeah. But there is a default case, default value case. Yeah, I'll talk about that. Yeah. Here, we assume there is no default value provided. Otherwise, later, if we add a default value, then won't be rejected because it can use default value, right? But here we assume we do not add default value, then it will be rejected if you use this not null constraint. Yeah. So that means the input value for that particular field has to be provided at the input time, not later time. Okay? Otherwise, this data entry cannot be successful. Okay? Yeah. The whole data entry cannot be successful. Yeah. So you need to make your decision based on your business. Yeah. So you need to provide, rationale, so why you want to do this. Yeah. So that's a business decision. Yeah. But in our database design, yeah, so we have, these cases. Yeah, so we can choose. All right. Yeah. So here you can see Pinot. Yeah. Here, the example I use from the company database. Yeah, so this is this line. The company database, that is our default database. Okay. Yeah. So if we do not see anything here, that's our default database. Okay. Yeah. In the company database, there is a project table. Then the project table, there is a project number field, Pinot. Project number, P number. Yeah. But the project number, yeah, in two different tables, the field name is different. In the project table, we use P number. P, then number. Yeah. But in other tables, we need to refer to the project number, right? So then we change. So other tables, we use P, no, this number. Yeah. We intentionally use different field names. So when you see the name, you can realize it's in a different table, not a project table here. So Pinot here, you do not want that null value. Okay? So Yeah. And here, we do not provide the default value. That means at the input time, the specific project number must be provided. Otherwise, the data entry won't be successful. It will be rejected by the DBMS. Yeah. All right. Implicit, yeah, because there is implicit case. Implicit case, that means you do not need to specify this constraint. Yeah. That's for the primary key case. If you declare a field as a primary key, then this constraint is automatically included. Yeah. So that's the implicit constraint. Yeah. Not null constraint. Yeah. Then default value. Yes. Yeah. Sometimes, yeah. You don't want so for a field, you do not want to allow null value. Yeah, because null value, you delay some work, right? Yeah. It's a warning sign. You need to fix the problem later. Yeah. So you don't want to delay that fixing work. Yeah. So you want to fix the problem at the input time. Yeah. But sometimes the value is not known. Yeah. But you feel if you use some appropriate default value, then you can make the input successful even if the value is not provided. Yeah. But you don't want to use that null value. Yeah. In that situation, yeah. So you just use the default clause. Yeah. Default, after that, you specify the default value. Okay? Yeah. So in that case, yeah. So with default case, then you don't need to worry about the null value, right? Yes, because default value is always used when the specific value is not provided. Yeah. All right. Yeah. If no default clause is specified without not null constraint, it takes null value. Yeah. Without null constraint, so you allow to use the null value. So null value is used. With null value, not null constraint, insertion failure. Okay. So rejected. Yeah. Insertion failure. Okay. Yeah. But when you write a program, so in this place, insertion failure case, in this case, yeah, because when you write your web application program related to this particular point, yeah, you need to be aware of the how to make your users aware of the insertion failure, right? Yeah, because your user, after they enter some input, push the enter key, enter button, yeah, then they do not see the value is entered. They do not see the value is entered. Okay, yeah. So you on the page, you need to provide some error message. Yeah. Error message explain. Yeah. Yeah. For this particular field, you have to provide specific number. You cannot leave blank. Okay. If you leave blank, data is not provided, and the database design, in the database design, the default clause is not used, and we use the not null constraint. Yeah, so many conditions. Yeah. Then, so your blank input is not allowed. Yeah. But you need to tell your user, yeah, for what reason. Yeah. So that's, you know, So when you understand, the meaning of relationship about these clauses, constraint, default clause, so you understand what's going on, what you should do to fix the problem. All right, so that's the slide. So we finished part C of module 3. Next, let's move to part D. Actually, as I said at the beginning, that's actually the part A of module 4. So now I, bring it, I put it here. Because the original part D of module 3 about the constraint, about several different type of constraint, foreign key, those things, it's not that urgent, right? Because those things we can delay. Those things we will not use them in our query practice, so we can delay to next week. But this week, so we need to do the SQL query, the select statements. So let's do the select statement topic. So let's jump to so this part D. All right. After this topic, then we can do a lot of exercise questions. All right. Data retrieval by select statements. So for the SQL statements in this class, about 90% of the questions we do select statements. Other statements, because much simpler, we only need to practice a few times, that's enough. Only a few cases. But the select statements, it could be very complicated. So most of our practice focus on this type. D.1, basic form of select statement. The basic form, the syntax, the structure, 3 parts. So you can see we call select dash from dash where block. The 3 components we need to use to build each select statement. Let me explain one by one. All right. The format of the syntax like this. Select, the first part. After the select keyword, you need to provide attribute list, a list of field names, columns, attribute list, separated by comma. Separated by comma. All right. So that's the first component. Second, from. From, the general case, multiple tables. Multiple tables. So you want to retrieve data from multiple tables. So it should be a table list, a list of tables, also separated by comma. But at the beginning, so we just use one table. Later, we will use 2 tables. We combine, we join 2 tables. If more than 2 tables, it could be more complicated. But when we first, in our first round practice, we only work on at the most 2 tables. Later, for some more complex queries, then we can do 3, up to 3. All right. Where condition. You need to specify where condition, where clause. The condition part should be a Boolean expression. True, false, unknown. 3 logic Boolean expression. Later, we need to understand that 3 value logic Boolean expression. Now, not very hard, but you need to get used to the 3-value logic. Now, different from our, in our high-level programming language, we use 2-value Boolean logic. Yeah. All right. Yeah. Then, so let's understand. Yeah. But how to? For the first part, attribute list. Oh, I didn't change the color. Yeah. Let me change the color. All right. Yeah. When we make that attribute list, yeah. All right. Yeah. Then we use this concept, projection attributes. Projection concept. Yeah. So what's that? Yeah. The projection, we know this concept comes from math, right? In math, people use this projection concept. Yeah. So here we borrow the concept from math. So we, use the similar, projection. Yeah. We do some analogy from math. Yeah. So what's the projection? Here, let me draw a simple diagram in math. In geometry, so we use projection, right? Yeah. Suppose this is the, ground level, okay? Ground level, horizontal line. Then you have a line segment. So you place it on the ground with this slant way, angles, yeah, some angle here. Yeah. Then, you suppose the sunlight direction, from top. So then there is a projection of this line segment. Yeah. So this part is the projection of that line segment. So that's the concept from geometry. Now, from this diagram, you can see projection is shorter than the original line segment. Yeah, yeah. But it could be, yeah, in a special case. Yeah. So when your line segment is in this direction, then the same length projection. Okay. Yeah, yeah. Other than that, for the general case, yeah. So shorter than the original line segment. Yeah. So based on that, this property, so here we use this property in our database query. Yeah. What's the original line segment? So that's all the attributes in your table definition. Yeah. So because whole line segment refers to all the attributes or fields in the table. Okay, yeah, I do not write a lot of words in the table, because in your table definition you provide all the table field, right? Yeah. So that's the whole line segment. Yeah. But in your select statement, you do not need to list all of them, right? Yeah. Yeah. Based on your business needs. Yeah. In many of your business requirements, we only need to select some of the attributes, some of the fields. Yeah. Not necessarily all of them. Okay? If you select all the table fields, you can use that star. Yeah, you put the star, that means you select all of the fields. You do not need to specifically write, because it could be a long list. To save that, so you put a star there. So you list all the fields using the same order as you declare them in the table definition. Yeah. you preserve the original order. We know order is important, right? Order of the fields is important. So you take the original order. Yeah. All right, then projection of all the attributes. Yeah. Projection of all the attributes. Then you have freedom to select some of the fields from the original list in any order you like. Yeah. So you can change the order, any order you like. Yeah. So we all treat as a valid projection. Yeah. Field 1, comma, field 2, comma, field 3. Something like that. Okay? The projection attributes. Yeah. The select clause specifies the attributes whose values are to be retrieved in that order. We know order is important here. Okay? The order, you list in the select clause. Yeah, important. Yeah. Yeah. For this projection. If you change the order, you get a different projection. Yeah. You use the same original attribute list, but you do different projections. You can do many different projections. Yeah. All right. Yeah. Then the select condition, where clause, that's select condition. Yeah. Yeah. The from clause, yeah, here from clause just list of table, right? Yeah. So very simple, very straightforward. Yeah. But later, when we move to complex queries, you will see the from clause also could be very complicated. Because in the from clause, we need to produce the tables. We need to write SQL statements to produce some of the tables. Yeah, that part could be complicated. Yeah. Not using existing table. Yeah. Here, this table list, if we use existing table list, that's easy, right? Straightforward. Yeah. But we can use temporary tables, yeah, not existing table. Yeah. So we make some temporary tables and we put them in the from clause. That could be very complicated. Yeah. But that's the later part. After the midterm, we will do that. Yeah. From clause. So here we skip, yeah, because we do not do in that way. Yeah. So the from clause specify the Boolean condition that must be true for any tuple. Must be true, yeah, but that means not false, unknown. Remember, there is an unknown value. And it cannot be unknown, okay? Yeah. Must be true. In the three-value logic, must be true. Other than false and unknown. Yeah. False, unknown. Yeah. Not. Yeah. Yeah. Right. Yeah. Select condition. Okay? Yeah. But how do you get unknown? Yeah. When no value involved, there is a possibility you get unknown. Yeah. Yeah. Sometimes you get unknown. Sometimes you may not get unknown. Yeah. But that topic, yeah, after we learn that topic, yeah, so you will know better. So here just give you some information, yeah, but not complete information. Yeah. Then retrieval select statement. Result returned. It's a multi-set of table. Yeah. Here we use the concept multi-set we learned last time. Okay. When you see this multi-set, duplicate tuples are allowed. Okay. Yeah. Yeah. Some of the rows could have the same tuple values. Yeah. Same tuple values. That's allowed. Okay. Yeah. Yeah. The reason, in many business requirements, people need that result. People need that result. Yeah. So it should be allowed. Yeah. All right. Duplicate can appear more than once. Yeah. Yeah. All right. Yeah. So that's the default case. All right. If you do not say anything, then that's the case. But sometimes you don't want to allow duplicate tuples, right? Yeah. So in that situation, you need to do something. You need to tell DBMS, you do not allow duplicate tuples, rows. Yeah. You need to do it explicitly. Okay? Yeah. But not a default case. No. Reasons not eliminating duplicate tuples. Yeah. Some reasons. The first, the user may want to see duplicate tuples in the result query. Yeah. This means based on the business requirement. The user want to see it. Yeah. Okay? Yeah. It's very common. Yeah. The user want to keep the duplicate rows. Yeah. But there is another reason. Yeah. Not another reason. Yeah. Because sometimes there is a situation. If you keep the duplicate rows or eliminate duplicate rows, both fine when you do some special data processing. Yeah, because when you do data processing, you may generate temporary tables, temporary search results. Yeah. Those temporary search results, so you use the data in the temporary tables. Sometimes both ways okay, right? Yeah. Keep the duplicate rows or eliminate duplicate rows, both fine for the temporary tables. Yeah. In that situation, then this point is useful. This point says duplicate elimination is an expensive operation. Now, you need to ask DBMS to remove all the duplicate rows. Yeah, it takes some time. Yeah, question?
So it's basically don't remove them because they're the same thing anyway. And so it wouldn't affect anything.
Yes,
You
yeah,
have
yeah.
resources to remove them.
You got it.
So if it doesn't cost you anything to
Right, you got it.
why
Yeah,
do- okay.
yeah, yeah,
That makes sense.
yes. Otherwise, you slow down. Yeah,
Yeah.
yeah. That operation is expensive. Only when you really need removing those duplicate. Yeah, your business requires removing duplicate rows. Then you have to do it. Okay, yeah, yeah, exactly as you explained. Yeah, all right. Yeah, just be aware of this case. Yeah, be aware of this. So that's why I talk about intermediate search results. Yeah. Intermediate because you have freedom to choose. Yeah. How to manipulate intermediate data, right? Yeah. All right. Yeah. So here, because that based on the internal algorithm, yeah, here we may not know the details. Internal algorithm, how to remove duplicate rows in the DBMS. Yeah. One way to implement, yeah, definitely this way, because one way, sort tuples first, then eliminate duplicates. That's one way to eliminate duplicate rows. But you know, sorting is expensive, right? Yeah. If you have large number of rows, when you do sorting, yeah, that's quite slow. Yeah. Quite slow. Okay? Yeah. Yeah. So just, yeah. Although we do not say the only way you can do sorting, yeah. Yeah. But so you may have some other ways, right? Other special ways. Yeah. 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 But an advanced way may rely on advanced data structures. So that's why we do not go that far. Okay? Yeah. So we don't go that far internal structure. Yeah. Store your data, organize your data. Yeah. Yeah. That part will we will learn in Module 5. Yeah. Module 5, we will learn a little bit. Yeah. Yeah. All right. Yeah. But you can do it. Yeah. So in your query, you need to add the keyword, distinct keyword. Select, after select, then distinct. Yeah. After select, before your attribute list, you put that distinct. So this keyword, you tell DBMS, remove the duplicate rows in the search result, in the query result. Yeah. Yeah. You get distinct rows. Yeah. 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 But in the case, the number of rows not too long, yeah, then you don't worry about the response time. Yeah. Because if you know the query results won't be long, very long, yeah. But if the query results very long, yeah, so you need to be aware of this operation. There is a possibility the response time is relatively long. Yeah. All right. So, and when an aggregate function is applied to tuples, in most cases, we do not want to eliminate duplicate. Yeah, yeah, yeah. Aggregate function. Yeah, later we will discuss. Yeah, several aggregate functions. Count, for example, average, sum, max, min. Yeah, those aggregate functions. Yeah. Sometimes we apply aggregate functions on the query results and we do not want to remove duplicates. Yeah. So that's, people do that all the time. Yeah. All right. D.2, remove duplicate tuples. Yeah. Here, let's just see some example. We use a simple example from the company. Yeah. So you get an idea. Yeah. All right. Example is very simple. The syntax, distinct. Select distinct syntax. Select distinct. Yeah. Column 1, column 2, a list of columns. After that. Yeah. After that, because we treat as tuple, right? Yeah. Yeah. The query result we treat as a tuple. So there's certain order. Yeah. So your distinct means the whole tuple value is distinct. Okay? The whole tuple value distinct. Distinct means the whole tuple value. Tuple values are distinct. Yeah. Not each column, okay? Yeah. So the group of, yeah. So in math, the tuple value, when you use vector, right? In math, a vector is a tuple. Yeah. So that's a group of data items, yeah, as a whole object, whole mathematical object. So you treat that as one value. So the tuple values are distinct. Okay? Yeah. All right. Example. Yeah. So let's use an example from our company database. Yeah. Look at this. Yeah. We work on dependent table. Yeah. There is a dependent table. Okay? Yeah. So we select two fields, two columns. Yeah. ESSN. ESSN means employee social security number. Yeah. The field name is ESSN. Yeah. All right, that field. Yeah. Then comma sex. Okay. Yeah, sex. So M and F, two values. Sex field takes two possible values, M value and F value. Okay. Male, female, M, F. Yeah. Letters. Yeah. Then we make these two fields together to form a two tuple. Yeah. So this tuple contains two field values. Yeah. So it's a tuple. Yeah. So then, in this statement, you eliminate all the rows with the duplicate row values, row tuple values. Yeah. If two rows the same, it must be one by one the same. Yeah. ESSN the same, and sex also the same. Then you treat those two rows the same. All right. Yeah. So let's look at the result. Here, I show you the result. Result you see, yeah, the concrete result you see like that. Yeah. After, yeah. Because some of the ESN could be the same. Yeah. You know, these two rows, ESN the same, but you know, the sex part F and M different. Then the whole row we treat different row. Those two rows are different. Okay? Yeah, so we remove all the duplicate rows after the statement. Yeah. All right. Yeah. So that's the, you know, simple example. Yeah. Next, then this is our most important topic in this part D. Yeah. Join two tables. Here I explain the logic joining two tables. Yeah. After you understand how to join two tables, then you are ready to work on many, you know, table join SQL queries. Yeah. All right. How to join two tables? Yeah. Let me use a simple example to explain the logic internal. Yeah. So I want to explain what happened behind the scene, because you cannot see it. Yeah. So you need to understand the logic behind the scene so you can understand it better. Yeah. So this question, yeah, we still use the company database. Retrieve the name and address of all employees from who work for the research department. Yeah. Research department. Yeah. So when you study at home, you can look at the database, yeah, because here, for me, it's not convenient to show you database, okay? But here, we're talking, we use two tables here, okay? The first table, employee table. The second table, department table. And they are related. Okay, there is a relationship. Okay, yeah. Department table, yeah, because department table there is a primary key D number, right? D number, department number, the primary key. But in the employee table, each employee, we need to store the information which department this employee belongs to. We need that information, but that one we use a field, DNO, okay, department number. We intentionally use a different number, different field name, okay, yeah. So in this way, these two tables can be connected. When you do the query, you can use the data from these two tables. In certain relationship, there is a relationship, yeah, all right. Then, these two tables are used. Employee table, yeah, so we refer it, use capital E. Yeah. Department table, yeah, yeah. Sometimes we don't want to type, because the first time you need to type the table name. The second time when you want to refer that table, you can use D, but you need to declare it. Yeah. So we call it alias. Yeah. Alias. Later we'll talk about alias. Yeah. All right. They are related. How to relate it? D table dot. Yeah. So we use this way to, refer the field in the table. D table dot D number field. equals eTable.Dino field. And we, in our where clause, so this condition we call a table join condition, because this equality is the way we join two tables. How do you join these two tables? So this is the join condition. Okay, so this condition we call the join condition. So that's the join condition. All right. So it combines two tuples, one from the first table and one from the second table, whenever their values are equal. How to combine? So in this slide, it's hard to see, but next a few slides, then you see more detailed information, so you can understand how to join. How to join? So I need to use a few slides to explain how to join behind the scene. All right. So the query statement for this example, this query example like this. Select. Then we need to know the employee's name. So first name, F name. So the field we use in the employee table. F name, comma, L name, comma, address. These three fields all come from the employee table. All right. Then from clause, we need to provide list of two tables. Employee, comma, dot department. Okay, and here in this one, we do not use the aliases. Here you do not see aliases. Aliases later we will add aliases. Okay, so here we do not use no aliases here. Okay, no aliases here. Later we will add aliases, more convenient. But without aliases, then dname equals research. This is the select condition. Okay, this is a select condition. Select condition. This is the join condition. Okay, join condition. Because here we do not declare aliases, right? So in this example, if we do not use aliases, then when you specify the join condition, you cannot use aliases. So there are two ways you can do. First way, you use the whole table name. Employee dot Dino, department dot D number, the whole table name. If you want to refer to table in that, that's one way. But you need to type a lot of characters, right? So that's the first thing. So most of the time, people don't want to type, long table name. People want to save some time, type strokes. But the second way, you can save typing table names. Here you just specify the field names directly. Because think about it. We intentionally use two different names. There is no confusion, right? If you use the D number in these two tables, it only appears in the department table. So DBMS can locate it without any confusion. All right? So that's the reason. You don't need to type the table name, because DBMS can find it based on the information given. All right. Dino, because it only appears in the employee table. So the DBMS looking for Dino. So which field is called a Dino in these two tables? And it can find it without confusion. So that's the reason you do not use aliases, you do not use the table names, you just type the field names directly without referring their corresponding table names, DBMS still can do it without confusion. Yeah. So that's our, first join example here. Yeah. All right. So the result, then, the rows that satisfy this requirement will be returned as the query result. Yeah. Yeah. All right. Yeah. So that's our first example. Yeah. Yeah. All right. Yeah. Then understand table join. Next, we need to understand what's going on behind the scene, the logic, what happens. Yeah. Actually, it takes several steps behind the scene to complete the table join in a DBMS. Yeah. Inside DBMS, the DBMS needs to follow these 4 steps to complete the table join. Yeah. Here, I give you that background to help you understand how it works when you join 2 tables. Yeah. But here, there is another thing I want to mention. Yeah. Because many people, so when they answer the questions, when I give you homework questions, answer questions, because some people search the web, and some people, ask tutors, because you get an answer from different places. Yeah. There are many different forms. So the same question, people can use different ways to write the answer. Yeah. All of them could be correct. Yeah. Yeah. Because you will see when in our previous example, when we write our query statement, you do not see the join keyword, right? The join keyword. Yeah. Here we do not use join keyword. Yeah. So that means we use the default join. So here because here what do? We join 2 tables without using the join keyword. That means we use the default join case. Table join, there are several cases, but one of them is the default case. If you use the default case, you do not need to use the join keyword. Yeah. But when you try to find the answers, examples from the web, many times, different authors, when they write the similar statements, so they may use that join keyword. Yeah. Left join, right join, inner join, outer join, many different type of joins. Yeah. Okay? Yeah. Yeah. Actually, our default join is the same as the inner join. Yeah. There are several join types. Okay? Inner join, outer join. Yeah. Yeah. Mainly, yeah. So our default join is the same as the inner join. Yeah. So if you use the default join, you don't need to write anything. Okay? Yeah. Inner join. Yeah. Yeah. So, but sometimes you may see people write the inner join. All right? Yeah. Yeah. All right. So if more than one table is specified in the from clause and there is no where clause, yeah. So all right. When we understand the table join, the first step we understand in this way. Yeah. We remove the where clause. We join 2 tables, but we do not apply any join condition, any condition. Yeah. Where clause, we may have several conditions we need to apply on the joined table, right? Yeah. But in order to understand step by step, the first step, we do not look at that part. Okay? We just join 2 tables. Given 2 tables, let us just join them the first time. How to join in the first time without any condition. Yeah. Yeah. So that's the, in this case, we use a cross product concept from math. Yeah. All possible tuple combination. What's the cross product? All possible tuple combinations. That's called a cross product. Cross product, that's a concept from math set theory. Okay? Set theory in math. There is a cross product concept. Yeah. Cross product concept. Yeah. What's that? Here, let me see. Yeah, Cartesian product. Yeah. People also call it Cartesian product or cross product. Yeah. Yeah. So what's the Cartesian product? Let's review a little bit. In set theory, a Cartesian product is a mathematical operation that returns a set from multiple sets. Yeah. So you combine multiple sets in some specific way. Cartesian product defines one special way to combine elements from multiple sets. Yeah. All right. Here, let me describe Cartesian product of two sets, capital A set and capital B set, these two sets. Capital A contains certain number of elements. We use little a represent elements in capital, a typical element in A, capital A. Little b, we represent a typical element in capital B. Yeah. Cartesian product, so you create a tuple here, right? Parenthesis around A comma B. Yeah. So that's a tuple, okay? Tuple with two components. Yeah. First component A, comma, and the second component little b. Yeah. So you look at all these possible tuples formed from elements from both sets. That group of tuples, so we call them A cross B, Cartesian product of A and B. That's the definition in math. Yeah. In our computer science, the database context, we use the similar way to form Cartesian product of two tables. Yeah. So you do the analogy. Yeah. Yeah. All right. So the analogy, yeah, let me do the analogy, okay? Yeah. Because let me use table 1, T1 and T2. Okay? T1, T2, two tables. Yeah. T1, we have a list of rows. T2, we have another list of rows. Yeah. T1, yeah, let me use little t1, little t2, little t3. Okay? Yeah. Here I just use 3 rows. Yeah. You get the idea. Yeah. T2, we have S1, S2, 2 rows. Yeah. Now we want to do the Cartesian product of these two tables. Yeah. T1 cross T2 contains all those tuples, all the possibilities, right? Yeah, let's see. Yeah. T1 comma S1, okay? Yeah. T2 comma S1. T3 comma S1, okay? So you use all S1 with all the T rows, little T rows. But another case, T1 with S2, T2 with S2, and a T3 with S3. Oh, sorry, S2. Yeah. That's all the possible combinations you can use from the rows of these two tables. All right, so then you can generalize this combination approach to the general case. Cardinality. So you count the number of elements in the Cartesian product. So we call it, so number of elements in a set, we call it cardinality. Okay, all right. So we use the vertical bar, absolute value. So here, when we apply, the absolute value sign on sets, we mean cardinality. Okay, yeah, not the absolute value meaning. Yeah. All right. So the cardinality of A cross B equals the cardinality of A times cardinality of B. The number of elements in set A times number of elements in set B. So here, the cardinality of T1 is 3, right? Yeah. Equals 3. Cardinality of T2 equals 2. And here you see elements 3 times 2, you have 6 elements. The product of the cardinalities from individual sets you use to make the Cartesian product. It's true for 3 set Cartesian product, 4 set Cartesian product, multiple set Cartesian product. Yeah. So this way. Yeah. All right. Extended to database theory. Yeah. But when you do the extension to database, you need to make small modification. That is, each table you allow duplicate rows, right? Multi-sets, duplicate rows. So when you make the Cartesian product, you do not remove the duplicate rows. So those rows with the same tuple values, you treat them as different objects when you make Cartesian product. That's the way you make Cartesian product. Okay? So apply Cartesian product on multi-sets. You do not remove the duplicate rows. Okay? You keep them. Keep them, but you just treat them as different rows. Okay? Yeah. You use your imagination to treat them as different rows. Yeah. All right. Yeah. Digest table drawing operation. Let me see how many minutes. Yeah, because I want to complete this part. Yeah. When you work on our homework questions, you need a background knowledge from this D.4, digest table drawing operation. That 4 steps to complete table drawing internally, yeah, to help you understand better. Yeah. So let's complete this D.4 before the end of this class. Yeah. All right. Yeah. When we join 2 tables, the first time, step 1, this is step 1, join 2 tables with cross product without considering join condition. Yeah. We can join, right? Without join condition, we just list all the possible combination tuples from 2 tables. Yeah, we can always do that. Okay? Yeah. So that's the first step. Yeah. So you can see, yeah, there is no problem to do this first step. Yeah. All right. But always work. Okay? This step always works. Yeah. Then after the first step, then you need to add conditions from the where clause one by one. The first time, let's add a join condition. Yeah. We need to remove those rows that do not satisfy the join condition. We know join condition. There is equality, right? Join condition equality. So you apply that join condition equality going through all the rows in the Cartesian product. In the Cartesian, you have large number of rows, right? Yeah. Only those rows that satisfy the join condition, you keep them. Other rows you eliminate. All other rows. Yeah. So that's our step 2. Apply the join condition. Yeah. Use the imaginary tuple variable to go through all the tuples. Yeah. So here, there is an imaginary tuple variable. Because you need to go through all the tuples, right? Yeah. From beginning to end. So every time you look at the current tuple, right? Current tuple, you imagine there is a tuple variable taking the current value for the current row. Yeah. Yeah. So that's, when you look at it, you compare. You use the join condition to see if this tuple satisfies the join condition. If it's true, you select it. If it is false, eliminate it. Yeah. So that's the step number 2. Yeah. All right. Only select those tuples that satisfy the join condition. Okay. Then step 3. Step 3. Apply the selection condition. Yeah. The department name should be the research in the previous example. That's the select condition. Yeah. So you want to go through all the survival rows. Yeah, the selected rows. Those rows you selected in the previous round. Now you apply select condition to check. Selection condition to check. Okay. Yeah. On the result table, intermediate result. That's the intermediate result table. Yeah, not the final result table. Yeah. On the previous result table, yeah, apply selection condition. Check. Yeah. All right. Then after that step, the last step, make projection when necessary. Yeah. Because in your select clause, you specify a list of attributes. So you describe your projection list. So the last step, you need to only take those field names, the values under those field names, and in the given order, in the given order in the select clause. So that's the projection step. Now you can see, after these 4 steps, step 1, step 2, step 3, step 4, you complete the whole table join operation. Yeah. So internally, DBMS follows these 4 steps to join 2 tables. Yeah. Here, the join, we do not say what type of join, internal, external, outer, inner, outer, inner, outer. Yeah, we mean the default join. Yeah. Default join, inner join. Okay, so here we're talking about inner join. Inner join doing this way. Okay. Yeah. Then outer join, we will join table in different ways. Yeah. We will talk about that later. Outer join. Yeah. But this is inner join. Yeah. All right. So in this way, we get a final result. Yeah. Regarding the tuple variable, so you have the background to understand. When you write a program, you write a for loop, so you have a counter variable, right? Yeah. So yeah, used to that kind of thing. Yeah. Iterative. Yeah. So you usually use a, counter variable when you do each iteration. That variable. Yeah. Here, when we go through all the rows in a table, it's like we do iterations. Yeah. So we do a loop, for loop, while loop, iterations inside a loop. So then in order to understand the looping process, so we can use the imaginary tuple variable here. Yeah. Think of an implicit tuple variable or iterator. Yeah, iterator. Yeah. Because you need to get a control of the current row. You want to do processing. Yeah. So that control, that object, you need a concrete object represent the current row. Yeah. So that's the imaginary tuple variable. Yeah. All right. Looping over each individual tuple in the field. Yeah. Every time you take one tuple, yeah. So you follow the order, yeah, of the rows in a table. So one by one. So every time you select one, yeah, the current row, then you apply different conditions on it. Yeah. Yeah. When you understand the query statement. Yeah. Evaluating condition in the where clause, yeah, on the current tuple, yeah, on this tuple variable. Yeah. All right. Only those tuples that satisfy the condition are selected. Okay. Yeah. All right. Yeah. So that's 3.4. Yeah. All right. Yeah. Yeah. So 3.4 give you the background on understand table join. Yeah. Okay. Yeah. What happened behind the scene? Yeah. Yeah. It's important. Yeah. All right. So because when we write a query statement, yeah, so here let's consider join two tables, that situation. Yeah. So you want to understand the logic, yeah, you know, what happened behind the scene. Yeah. So you need to, you know, imagine how to organize your data to produce the desired result. So this background would help you to do that understanding. Yeah. All right. Yeah. So the last one, let me leave next time. Yeah. Illustration example. So you see the, you know, what happened. I use a concrete example to show you. Yeah. 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 But yeah, let me leave it next time. So after you see this concrete example, you can understand better. Yeah. Because in our D.4 discussion, it's pretty abstract. Pretty abstract. We need to use a concrete example to understand better. Yeah. Yeah. But today we don't have that much time. Yeah. Yeah. So let's do it next time. Yeah. All right. So so today Thursday, so I try to post home assignment number 1 late tomorrow night, yeah, Friday night. Yeah, yeah. It could be very late. Yeah, I need to make those 10 questions. Yeah. 10 questions I want to do this way. Okay. 5 questions I use the company database. And the 5 questions, I use that W3 school, there is a database, right? Yeah, so you can see the data. Because the reason I do that way, I'm afraid some students haven't installed, get the software ready, yeah, you know, install the company. Then, you know, W3 school, you can do the testing, yeah. You can do the hands-on, you get experience from W3 schools. So 5 questions from W3 schools, 5 questions from the company database. Okay, so in this way, even those students, they haven't installed the software successfully, yeah. But definitely the best way is you need to install XAMPP software successfully. Yeah. But some students you can use, you know, other database displaying tool. Yeah, that's fine. Yeah. Yeah. All right. Yeah, that's it. Yeah. So let's